Alright, I must say, this is kind of an unusual situation to me. I'm here by the airport in Kiev, to be more precise, in front of the airport, speaking to you. Hello, Minsk. Uh, it's because of Ukrainian International Airlines who made me stuck here because I missed my connection to Minsk. So you probably all know that coupling in time and space in software is something that we try to avoid, right? Um, but there are some kind of situations in which I would like this coupling in time and space. Like, for instance, now I would like to be at the same time in the same room as you are. I still hope to make it at 6 o'clock for the last slot, but if that's not the case, I'm sorry. I wish I was there, but you can't always get what you want. Things just happens. So I wish we could have this synchronous communication. Old-fashioned request and response, and when you have questions during this presentation, you could normally ask them, and I would respond, like request and response. But that's not gonna happen because because I'm here and you are there, right? So we have to make it message driven. If you have any questions about this, just feel free to ping me on Twitter. I will be happy to reply to each of the questions. All right. Speaking about being message driven, I would like to talk about event driven architecture traps. So event driven architectures, they become more and more popular. They earned their place in software development, and that's good. But I feel that we don't talk much about problems that we might encounter with EDA. So it might sound a little bit pessimistic, this title, but trust me, it's not, because for each of the traps that we are going to see today, there will be a bunch of reasons and solutions to solve it, and reasons not to get trapped in the first place. So there's a track coming by right now, so probably we'll have some background noise during this talk, for which I would like to apologize, but believe me, that's the best spot I could find in here. Alright, so since I have a little bit more time than 30 minutes because it's asynchronous, right? I'm going to talk a little bit about disclaimers that I would like to share with you before we start. These are traps based on my private experiences. So that happened during the work with my previous teams, and they were traps in my context. And in the same context, we found solutions. I don't know, maybe there is like some kind of literature behind these solutions. For some of them it is, but they worked in our context, okay? And about this one, I'm not pretty much proud of, but I haven't pushed anything to production since 6 months. I have a different role right now, but those traps are based on previous experiences. So even before 6 months, when I was able to push to production even on a daily basis. And this is completely new content, and I'm sitting next to the Kiev airport, and there's a lot of people coming by in trucks and cars, so please don't throw tomatoes. Alright, let's get it started. My name is Jakub Pilimon. I work as a Spring Developer Advocate, and which means that I get the privilege to face a lot of smart people like yourself. And if you think that I may have any answers to your software problems, especially when it comes to domain-driven design, event storming, test-driven development, or Spring, feel free to contact me on Twitter, or I also run a blog. I'm a co-founder of DDD by Examples. About that, I'm very, very excited because it's a set of projects. You can find them at GitHub that they aim as a bridge between Spring and DDD, so it's end-to-end DDD with Spring and Java. So feel free to ping us if you want to collaborate. let's get it started. Let's build a common foundation for our talk. What is event-driven to me? To me, it's nothing more than a pattern that promotes detection and reaction to state changes, and these state changes are represented by domain events. That's a definition that I would like to go with for the rest of the talk, okay? That being said, we'll have to bust some myths about event-driven architecture. It doesn't mean that you have to have microservices if you want to be event-driven. You can be event-driven with a monolith application, and that's fine, all right? You can have two components in a monolithic applications. Those two components may live in the same process. They might communicate via events just by in-memory calls, okay? The same with message brokers. You don't have to build message broker infrastructure for event-driven architecture, because events might be transported via different mechanisms, like HTTP, for instance. That's fine. We already have talked that events can live in application memory. We can transfer them in memory. That's fine. You can be still event-driven. And to be honest, they might not be even visible in the code, but they are there in the business process. Maybe they are hidden by state transitions, by mutation, but domain events, they are in the business process, and we have to find them. And we'll talk about event sourcing too. What event sourcing is, we're gonna see in a while. So this event-driven traps we're gonna see will come in a different setup. So to be honest, in fairness, two different setups we are going to see are this setups and variations of this. So the first one, when you just have one component talking to the other one, they may be in the same database and they may be the same process, live in the same process. So it might be monolithic application with one database. There might be microservices. There might be memory call when it comes to monolith. There might be a REST call or a JMS or MQP, whatever it is. The common thing is that the delivery of the event is destructive to an event, which means the event is gone. When you finish your in-memory or HTTP call, it's gone. Even if you finish your MQP call, when it's delivered to all of the subscribers, it's gone. So that's the common thing when it comes to the first setup. The second setup is that not only you deliver events to your subscribers, but also you can store them in some persistent storage, like database, for instance. They are kept there forever, all right? And this has several implications, like, for instance, if the subscriber builds its internal state based on those events, that means I can quickly recreate this state just by reconsuming those events from scratch, right, in the same order. And this is what event sourcing is about. All right, so let's jump into the first trap. It's called missing an event. And it doesn't mean that I have Rabbit and I just missed some event because Rabbit didn't deliver that. You're gonna see that I'm going to talk about something different right now. So let's imagine we are building an e-mobility platform. And we want our customers to be able to charge their car. So it's kind of a common use case when it comes to mobility, right? So in a nutshell, it might look like this. I have a customer which drives and plugs into the socket. The backend, or not the backend, the charger sends a start transaction signal to our backend, and for backend we are responsible, right now. This protocol, the start transaction, is built into the firmware of a charger, right? And then customer finishes charging, the charger sends stop transaction to our backend, and customer unplugs and drives away, right? This is how it looks like in a nutshell, and this is a simple controller that might be able to talk with our charger, to accept things from our chargers. Like there is a Postmapping from, hey, the transaction should be started right now and should be finished. So there is /starts and /ends Postmapping. So just ignore the fact that there is add transactional, and I probably shouldn't do this kind of logic in a controller. I know that, but let's just ignore that for a while. So we have the starts, we create a new session, we have a start time, which is basically right now. And then we have a post mapping for ends. We find the session. If it's not there, we throw an exception, and mark the session as finished, and just save it. That's it. But you might have noticed that we are just throwing this as an exception when there is no session, right? And in a realistic scenario, things might not be that optimistic as we wish them to be. So we might have missed somehow the situation that the transaction was started. Maybe our database didn't store that. Maybe it stored it in a corrupted way. Whatever it is, the charger will be released only and only if the stop transaction signal is successful. So it doesn't return 400 something or 500 something. In the case of illegal state exception, I'm going to return 500 something to our charger, and that means that our customer is stuck at the charger and calling customer service, and this is not what we call customer-friendly solution, right? So what I'm getting to is that we are not able, or we are not allowed to throw this exception when the transaction wants to stop. Why? Because we are missing the fact that it's an event. It might look like a command, stop transaction, but in the business process, the customer stopped charging, and the charger wants to just notify us about this. So we cannot ignore, we can ignore this fact, but we cannot deny that this fact happened. So this is an ultimate difference between command and an event. Command can be denied because it's the thing that is about to happen. Event is something that has happened. I can ignore that, but I cannot deny, of course, right? So I cannot just throw an exception. To be honest, this call at Postmapping should have been wrapped in a try-catch, and we should have dealt with that somehow, like maybe store a charging session which doesn't have a start date and deal with that later, right? So this is a customer-friendly solution, business process-oriented, because this happened, right? I cannot deny that. So what are the reasons to get trapped into this trap? So first of all, we treat boundary of our software as equals to boundary of our business process, which is not correct, right? The business process is broader than our software. And also, we sometimes, and quite often, we miss the fact that our piece of software might be not the source of truth of things. Like in this situation, we are just downstream to events that happened in the real world, and we are not the single point of truth. So we cannot just enforce this kind of invariance like, hey, if there is no session in my database, I'm going to throw an exception, right? So we missed that event, even though there is no event which is sent via, I don't know, RabbitMQ or something like this. In the business process, there is an event. Charging session was finished, and what pushes us into this failure even further is that there is a semantics of the protocol and there is technical implementation of this protocol. And I'm speaking about right now about this charging session protocol. So there is start and stop transaction. They might look like a command, but in our business process, they are just used to notify about an event that happened. So there is like some technical things when it comes to the protocol, and there is semantics of the whole communication. And this is the most important thing. We don't have control over this protocol. It works like it works, but still, there is a main event we cannot deny. So, a couple of solutions. Event storming, which is a technique which can allow you to find external and internal events that happen in your domain, is a great technique. It allows you to find those external events and boundaries of your software. So I encourage you to play around with event storming. Also, think about assumptions you make about consistency of your software, and don't try to be consistent no matter what. It's okay to say that in our inventory we have less books that we really have in our bookstore, or even more. Actually, is the only thing to go. Is the only way to go, because we are just downstream processor sometimes to the event that happened in the real world. If you don't agree, so think about this: how we are going to teach people who are going to steal books from our bookstore to check them out properly, right? So it's okay to be eventually consistent and attached to semantics of the protocol, not to its technical implementation. So focus on intention of any communication in your system, if it's an event or if it's a command or maybe it's a query. All right? So having said that, let's jump to our second trap, which is versioning of behavior. This is fun. Let's see this scenario. We have this stop transaction, and our backend this time correctly identifies this as an event and sends somewhere. out there, and there is a taxes service which is responsible for calculating taxes. So it does it by listening to charging session finish, and whenever this happens, it's going to calculate and insert tax in its internal database. And also those events will be stored somewhere in our event store for future use. So they are going to be persisted forever. Alright, so this is a simple code that can give us this expected behavior. Like, we are listening to charging session finished events. We get the rate, which is basically hard-coded. It's 15%. It might be configuration, of course, database, so that we don't have hard-coded values, but you know the concept. It's like a value taken from somewhere. And then we calculate tax and store it. So here is the problem. And there's a truck coming by again, so there might be some background noise right now. Here is the problem. Guess what? Tax rates, they change a lot, right? Like next year or next month, the tax rate may be 16%, right? And it's quite possible for that to happen. So what we do? Of course, we can deal with that. We can change this code to get 16. If it's in database, we don't even have to redeploy our code. But then, if we want to just recreate our state from scratch by consuming all of the events from the very beginning, we should end up with the same state, which will not be true when we change this value. So what we do? We can do an if statement, right? If event happened in 2016, then give me 0.15. If it's 2017, give me 0.16 or things like this. So we have this branching logic. And then we have like 10 if statements if tax rates change a lot. And we have to repopulate those if statements in all of the consumers that have this kind of logic. So it escalates pretty quickly, right, with these if statements. So here's the thing. Whenever you have this branching logic in your event handler, whenever you think about doing this complex branching logic, you're probably missing a fact that you should have been done some calculations at the time of creating the event. And the result should be kept inside of the event as a part of the payload. And that's it. So you can take the rate from the charging session finished, and that way you don't have to deal about this problem with, hey, this value is not temporal in my code, but it's temporal in the real world, right? So we could just have an event get rate and you are done. In fact, the same thing happens when it comes to external calls, which we are going to talk about in a while. But let's think about the reasons. So there is hard-coded values which are not temporal, and we have to think about that. If you want to reconsume your stream, it's going to be problematic because you are going to end up with a different state. So one of the problems with hard-coded values is occurred time versus arrived time mismatch. So if you do instant.now, for instance, in your instant.now, for instance, in your event handler, that again means that you are hard coding some values, right? And that might be a problem because instant.now is going to be different when you are going to repopulate your events from scratch. So think about processing time and really the time of when the event has happened. These are two different things. Solutions. So again, calculation logic in projection. So in the event handler should be done at time of event creation, and the result should be kept inside of the event. And same with external calls. If you want to do external call in your event handler, most probably you are missing some call at the time of event creation. And let's talk about something different when it comes to external calls. Imagine that we decided, for some reason, whatever it is, to do these external calls. So whenever we have the charging session finished, in taxes we call a service which is called tax rate, and it's going to reply with a tax rate. So think about it for a while. Let's say our taxes service is down, right? And it doesn't respond. That means we'll queue up all of the events and wait for the tax service to be alive again. So let's say there's like 10,000 of those events because we don't monitor taxes service that maybe properly, and maybe we don't care if it's down for 2 or 3 hours. Whatever it is, at some point it will get back again and live again. And it's going to do what? It's going to do a couple of not couple, 10,000 calls to tax rates, meaning that tax rate is now down and its external consumers are down. Which is not the thing you would like to see, right? If you don't have, of course, like circuit breakers, but all of a sudden you have like this cascading failures, which is bad. All right, let's see how to deal with that. Again, reason, thinking that external systems are temporal, just like hard-coded values, they are not, and relying on single point of truth. So there's nothing wrong with making your tax rate system to populate events or to emit events each time there is a change in tax rate, so that your tax system can build its internal state of events of tax rates, and it doesn't necessarily need to call anyone if you want to have tax rate. So that means you just join two stream of events: charging session event, charging session finished, and tax rate finished. The tax rate change, excuse me. So again, external calls should be done at the time of event creation, and the other way to deal with that is just to have this stream join. So I'm joining two streams and building internal state. But be careful with that, because that creates coupling between two streams. They now have to be replayed always together. Trap number 4 is ignoring cap theorem. So cap theorem, what it is, you probably know that you are able to only have two of the following three things: being able to be consistent in your distributed system, or available, or being tolerant to network partition. So let's see. We have the stop session signal. We find our session, we mark it as finished, and we publish an event charging session has finished. And it's all transactional. So the things look like this. We have find in the repo, we mutate our state, we publish event, let's say to Kafka or to Rabbit, and then the proxy in Spring or whatever it is trying to commit to your database. But guess what? You might have been successful with Kafka, but your database might be down. And you announce to the whole world, hey, I produced event, I produced charging session event, and there is no event when it comes to there's no state change when it comes to your database, right? So this is not something that I would like to do. We have to do something different. Probably you can just rearrange rearrange calls. You can do first database call, commit, and after all register a transaction synchronization callback that will just publish the event if and only if the commit was successful. So this is like at least once delivery, because you are going to fire and forget to Kafka. If Kafka is down, you won't get an event. So we can just store both of them in the same database, event and charging session. And then we have external scheduler, which will pick up the events which are not processed and send them over. If that is the case, you might process events, you might send those events several times. Why? Because the same situation may happen. So you need to mark your event as sent in your database after publishing to Kafka, and then your database may be down even though you published successfully. So it's called at least once delivery. If you have idempotent consumers, that means you are able to get something which is called exactly once processing. All right. So here are the reasons. Ignoring the fact that every now and then things will not work, right? So maybe experience with two-phase commit now is a reason. I think so. And trying to be consistent, like all the time. It's okay to be eventually consistent. Just embrace it. Your business is most probably eventually consistent. With solutions, at least once, we talked about that, at most once also. So event sourcing, when you rebuild state from your events, that means you only have to modify one single point of source of truth, which is event store. Log tailing, when you just connect to your internal things in your database and just tail logs from tail transactions from your transaction log, and listen to yourself, which means you are both publisher and subscriber to one channel of events, and you change state when you get the event that you just published. All right, so then you are eventually consistent with your state of your charging session. All right, trap number 5, Anomic event. What does it mean, Anomic event? I'm talking about events which look like this: old state and new state, field 1, field 2. Old state was different, new state is also different. Which means, like Anomic entities, you have setters and getters. There is no difference between that. That's why I call it Anomic events. Why it's a trap? Because you might have multiple reasons to basically have the same state change in your application. Multiple business events that will end up in the same change in your database. So you're missing a behavior, a business intent behind this state change, and that's wrong because it's not only for analytic reasons but for business logic. It's kind of good to have the information why the change is there, right? So it's the same like with calling setters and getters in your services for multiple reasons. So there are like multiple reasons that will end up in the same state change in your database, right? So reasons, focusing on data instead of behavior. So the ultimate problem when it comes to programming, right? And solutions, of course, domain events with behaviors, not events like state changed, but domain events with intention. And think about business intent of any change, not only about the representation of that change. So we have to find those events. And event storming, of course, again, it might help you. The last trap is versioning of events. What does it mean? It's the ultimate trap, and I think the most common one. So why I cannot just change my data in event store when I have like corrupted data or typos or things like this? Think about it. There are several reasons why you shouldn't do that. Because it's a natural audit log, and audit log shouldn't be processed and changed because it's a not audit log if you can change it, right? There is like a business reason. And technical reason is that you might have cached your events somewhere, because if events are immutable, they can be cached forever. And if they are mutable because you change your audit log, that means your cache is like useless right now. So there are technical business reasons not to do that. But let's see if you really want to evolve with your event schema, let's say, because business evolves. We have to react to market drivers, and at some point we of course have to change the version of the event. Let's say we produce charging session finish, and now we want to produce charging session finished version 2. So we have two different consumers. One of them migrated and is able to process the version 2. The first one is not able to process version 2. So we can just do blue-green deployment with two different handlers, and each of them will be able to produce to consume each version of events. That would be the handlers, so charging session finished and version 2 finished, and so on and so forth. The problem is that I would like still the version 1 to be able to operate. So here is the thing: you can do something which is called dual write at the side of the producer, which means the producer will send two events at the same time, version 1 and version 2. That solves some kind of a problem, but there is also a problem. You would like to reconsume state from scratch, and then version 2 has problems because it doesn't understand version 1 from the past. So what you could do at the version 2 handler, you can just upcast the event from the version 1 to version 2. Maybe you just added customer name, and from the past event you just didn't care, so you just passed you don't care as the customer name. That way you are able to operate with live and historic data at both consumers. It's version 1 and version 2. It's called dual write, but it's problematic because it's based on type schema. It's type schema. If there is a new event, new type, I'm just operating on types, version 2, version 1, and so on and so forth, by headers in here, whatever it is. It's problematic because the change is additive, right? It's backwards compatible. So in this case, I'm able to do this. If I have customer version 2, I'm just adding a new field, right? Which doesn't mean necessarily that I have to migrate something, because this will do the trick. This is called weak serialization, right? If I don't rely on types of the events, but I'm focusing on payload, for payloads which don't have customer names, I will just pass don't care, I don't care, and for the current events, it will be overridden by a real value from the payload, and that's it. You just need to add the customer name when you are ready with your consumer, and you can redeploy. And that way you can just process old events and new events. If the change is additive, of course. If it's not additive, if it's a typo, dual write might help you. There's also a thing which is called copy and replace. If you really want to just change your corrupted data, if you really want to do that and really want to like reconsume your or recreate your stream of events, and you really want to like get rid of some typos and old events, you can just have a translator which will process old versions from old stream and produce new version, apply some kind of transformation, maybe this correction, whatever it is. It can be the same value with upcasting. You delete the old stream and you create a new stream. So versioning of events problem using strong schema based on type, for instance,
canonical shared model for your event. It creates a high degree of haptics, so just please don't do that. Don't share with your between your microservices canonical model. Solutions, dual write, weak schema, copy and replace, can deal with everything. And schema server, you might do it, but it like requires an additional thing in your infrastructure. All right, that's it. Thanks for listening. I hope to see you in Minsk still. I hope I will make it. So this is the code. You can check it out. Thanks. Bye.